Hi, welcome back. This is Professor Ridge and today's lesson on section 5.8, application of polynomial equations. So let's first define what a polynomial equation is. It's just an equation where you set two polynomials equal to each other. Okay, so example, we know polynomials are like 5x to the third plus 2x minus 7, so that's one polynomial, and we set it equal to another polynomial. It could be as simple as just one number, or 6x plus 8, something like that. So that's a polynomial equation. 8xy squared plus 3x minus 7 xy equals 2. That's a polynomial equation. Now, what's a quadratic equation? So a second degree polynomial equation in one variable. This is real specific. That's called a quadratic equation. So an example would be something like 3x squared minus 5x plus 7. That's quadratic. And then equals 0 or equals another expression. Now the degree of an equation is equal to the highest degree term, just like it is for a polynomial. So it's the highest degree of either polynomials. Okay, so this is degree 2, and it's the single variable is just x, or it could be just y or whatever, but it can only be one variable. That's key to be a quadratic equation. Alright, so how do we solve quadratic equations? Okay, and before we answer that question, we got to pick up a concept here. So it's called the principle of zero products. For any real number, so for any real numbers a and b, if a times b, that's a product, is equal to 0, so that's why it's principle of zero products. The only way that that can happen is if either a equals 0 or b equals 0. And then vice versa, right? It's actually if-then statement. If a is 0 or b is 0, then a times b has to be 0. So you can go the other direction too. I'm not going to write that down, but this is the one that we're going to be concerned with. Big idea. Okay, so we know from basic algebra that if we wanted to solve this for x, we would divide by both sides by 3, and x would equal 0. But we can also solve it using this principle, because if you have a product of two numbers equal to 0, then we know either 3 equals 0, which that's false, or x equals 0. Okay, so x has to be 0 in this case. Alright, now how does this help us with quadratic equations? Well, if we go a step further, if I had x times y is equal to 0, then x equals 0 or y equals 0. Okay, step further, if I had x plus 3, and instead of putting y there, I'm going to put x plus 2. So this is how we're going to use this principle. Is if we think of this as one number, and that is one number, we have a product of two numbers equal to 0, and by the principle of zero products, a equals 0 or b equals 0. So again, we're going to take that first factor, x plus 3, set it equal to 0, or the second factor, x plus 2, equals 0. And then you're going to solve each of those separately. So then you subtract 3 from both sides, x equals negative 3, or x equals negative 2. Alright, and see if I check. Look, check x equals negative 3. When you plug in negative 3 into the first parenthesis, negative 3 plus 3 is 0, and over here negative 3 plus 2 is 1. 0 times 1 is 0. And then if you check x equals negative 2, you get the 0 in the other factor. So negative 2 plus 3, negative 2 plus 2, does that equal 0? So you get 1 times 0, which equals 0. Check. So you can see you have two solutions. Alright, so now how does this solve quadratic equations? So hopefully you can see there, if you were to multiply that out, this is the same thing as x squared plus 5x plus 6 equals 0. So what you do is, if you have a quadratic equation, we want to factor it and have it equal to 0, so we can use this zero product principle. And then you're going to set each factor equal to 0, and then you're going to solve each of those. Okay, so that's the technique, and I'll write it down on the next page. So to solve a quadratic equation using the zero product principle, the first step, now remember, the zero product principle says that if a times b equals 0, then a equals 0 or b equals 0. So to use that principle, I've got to get this condition met first. I have to have it written as a product and equal to 0. So our first step is get it equal to 0. So you're going to move using the addition subtraction principle, get everything onto one side. And then your second step is you're going to factor it, because you want to write as a product. Factor means write as a product. And now once we've written it as a product and it's equal to 0, you're going to apply the zero product principle, or the principle of zero products, however you want to say that. And then so here we're going to apply the zero product principle. So you're going to factor, now you're going to set each factor equal to 0. Separately, right? And solve. Okay, so basically those three steps. If you want to call the and solve the fourth step, that's fine. And then of course you can check it. You should always check in the original equation, although you can check in one of the other ones, but typically you want to check in the original equation. Alright, let's try a couple of these. One more comment. The whole reason we did all of chapter 5 up to this point to solve quadratic equations is that we had to know how to factor. So basically we did all that work so we can get back to the business of solving equations, and now to solve quadratic equations, you have to know how to factor polynomials. So we had to do all that work so we can do that key step, factor. Alright, let me try a couple problems. Okay, so our first step is get it equal to 0, which it is. Now we want to get factor, so we're going to use its trinomial, so we do factors 20 that add to 12. So that is, let's see, 1 and 20, 2 and 10, that's it, 2 and 10. Bigger one's negative, signs are the same. If C is positive, these two signs are the same as B. Alright, so that's step 2, we factor it. Now step 3, you're going to take each factor, you're going to split it up, set them both equal to 0. And then you're going to solve each of those factors separately. So x equals 2, or x equals 10. Now if we're going to use a solution set, right, you're going to put it in braces 2, 10 brace. So you can write it either way. So this is doing a solution set. Alright, let's look at 14. So again, we're going to get it equals 0, which it is. We're going to factor, so it looks like 8t comes out of both of those. 3t plus 1. We're going to split up the factors, 8t equals 0, or 3t plus 1 equals 0, and solve those separately. We can use the zero product principle for that, or we can divide by 8, doesn't matter. Subtract 1. Divide by 3. So our solutions are negative 1/3 and 0. Let's try another one. Okay, so 28. So again, our first step is get it equal to 0. So you're going to subtract 45 from both sides. Or just remember the shortcut. You're going to just move the 45, change the sign. Okay. Now I want factors 45 that subtract the 4. So let's see, that would be 9 and 5. Bigger one's negative. Signs are opposites. And we go x minus 9 equals 0, or x plus 5 equals 0. That's step 3. You split it up and set each factor equal to 0. Now you're going to solve each of those separately. So x is 9, or I usually just separate it like that. And it's important, these are or statements. It's either x could be 9 or it could be negative 5. So either one of those are a solution to this equation, quadratic equation. So we got 2 solutions. Generally you get 2 solutions. There are cases where you only get 1, because you might get a repeated factor, and there's cases where you get none. So you can get 0, 1, or 2 answers for quadratic equations. Okay, so let's look at 38. Again, I want to get it equal to, now this is not a quadratic equation, this is a cubic equation. And we use the same technique. So I'm going to subtract 40a, because I want to get it equal to 0. And then we're going to factor. A comes out of all 3 terms. This is a trinomial affects 40 that subtract the 3. So let's see, we get 8 and 5 is 40. Bigger one's negative. So to get the negative 40, these signs have to be opposites. And now that's factored. Now there's three numbers multiplied together equals 0. So you can extend that rule to as many factors as you want. If any one of the factors equals 0, the whole thing is 0, which would make this a true statement. So we have 3 possibilities. Either a is 0, a minus 8 equals 0, or a plus 5 equals 0. And we're going to solve all those. The first one's already done. So a could be 8, negative 5, or 0. So you got 3 solutions on this one. Alright, let's try another one. Okay, now this one, it's factored already, but it's not equal to 0. So we got to fix that problem. So what you have to do is you actually have to go backwards and re-multiply this out because it's not equal to 0. So you do the FOIL, z squared minus 2z plus 4z minus 8, negative 5. So then you're going to get z squared plus 2z, and then I'm going to add 5 to both sides. I'll just do that all at once. And now you can factor it. Factors the 3 that add to, no, that subtract to 2. So 3 and 1. Bigger one plus. Signs are opposites. Now set each factor equal to 0. Subtract 3. Add 1. And we're done. Okay. And I want to do one more. Well, we'll do a couple more. Okay, so 58 says let g of x equal 2x squared minus 15x. Find all a's such that g of a equals negative 7. So what we're going to do is we're going to plug in a for x. And we get 2a squared minus 15a. And then you're going to set that equal to negative 7. So we got 2a squared minus 15a equals negative 7. And we're going to solve it for a. So we can find all a's that would make this equal to negative 7. Okay, so it's a quadratic equation. Add the 7 to both sides. Now in scratch work we're going to do the ridge method, right? So we got 2a over 2. Factors of 2 times 7 is 14 that add to 15. So that's 14 and 1. We're put in signs. Bigger one's negative. You get positive 7. These two numbers have to be the same. Now I got to reduce it. So I'm going to factor out a 2 from the first one. I just write it above to save space. So divide 2 out of both of those numbers. What comes out of 2 and 1? Nothing. So it's done. And then the 2 that I factored out of the first parenthesis cancels the 2 on the bottom. So we've got a minus 7 times 2a minus 1 equals 0. Okay, so now I got it factored equal to 0. So I apply the 0 product principle. A minus 7 equals 0, or 2a minus 1 equals 0. And then I solve both of those separately. So we get that. So 2a equals 1, and then we're going to divide by 2. A equals 1/2. So our solution set is 1/2 and 7. So A could be 1/2 or 7. Okay, so the last thing I got to cover is it says find the domain F of the following. Okay, so remember F is not defined when the denominator is equal to 0. So what you do is you set the bottom equal to 0, solve that. So factors of 4 that subtract the 3, 3 and 1, no, 4 and 1, sorry. It's minus, plus. So x equals, since I'm running out of room, I'm going to skip some work. X minus 4 equals 0. I'm going to add 4. X plus 1 equals 0. I'm going to add negative 1. So x negative 1. Now you're going to throw these out. Because it's undefined there. So our domain is negative infinity to negative 1 union negative 1 to 4 union 4 to infinity. Okay, or I can write it set of all real numbers except negative 1 I can write it like this: set of all x's such that x is a real number and x cannot equal negative 1 and x cannot equal 4. So I can write it using interval notation or set builder, either way. Okay, so that concludes our lesson for 5.8. Go complete the exercises in my math lab. That also completes the chapter, so make sure you do the chapter tests, and I will see you next time.